What if I told you that soil is completely optional for growing vegetables? Not reduced, not minimized, completely unnecessary. Right now, you could be growing tomatoes, lettuce, peppers, cucumbers, and herbs with zero soil. No dirt, no mess, no weeds, no soil-borne diseases, and in many cases, faster growth and higher yields than traditional soil gardening. You're probably thinking this sounds impossible, that plants need soil to survive. That's what we've all been taught since childhood, right? Wrong. Here's the truth the gardening industry doesn't emphasize. Soil is just a delivery system. It holds water, provides support, and contains nutrients. But plants don't actually need soil itself. They need what soil provides, and you can provide those things without a single handful of dirt. This isn't some futuristic concept. Commercial growers have been doing this for decades. Massive greenhouse operations producing millions of pounds of vegetables annually use zero soil. NASA is researching it for growing food in space, and now you can do it at home with simple, inexpensive materials. Hey there, fellow gardeners and food production enthusiasts. Welcome back to Garden Soilless. Today, I'm revealing exactly how to grow vegetables without soil. Not theory, not complicated hydroponic systems that cost thousands of dollars. Practical, accessible methods that work in small spaces with minimal investment. I'm covering 5 distinct soil-free growing methods, from the absolute simplest, requiring almost no equipment, to slightly more advanced setups that maximize production. Each method works, each has specific advantages, and by the end of this video, you'll know exactly which method fits your space, budget, and goals. This is the future of home food production, and it's available to you right now. Let's dive right in. Section 1. Why soil-free growing works. Before we explore specific methods, you need to understand why soil-free growing actually works, because once you grasp this concept, soil-based gardening will never look the same. Plants don't eat soil. They absorb dissolved nutrients through their roots. In traditional gardening, soil holds these nutrients and releases them slowly as organic matter breaks down. But this is inefficient. In soil, most nutrients are locked up in forms plants can't immediately access. Microorganisms must break down organic matter to release nutrients. This takes time, it's inconsistent, and it's affected by soil pH, temperature, moisture, and countless other variables. Soil-free growing eliminates this inefficiency. You deliver nutrients directly to plant roots in immediately available forms. No waiting for decomposition, no nutrient lockup. Plants get exactly what they need when they need it in perfect ratios. The result? Faster growth, often 2 to 3 times faster than soil growing. Higher yields, sometimes double or triple traditional yields. Healthier plants, fewer diseases because soil-borne pathogens are completely eliminated. Better resource efficiency. You use significantly less water and zero fertilizer is wasted. Plants need only 6 things to thrive: water, oxygen, nutrients, light, appropriate temperature, and physical support. Soil provides water, some oxygen, nutrients, and support, but you can provide all these things more efficiently without soil. Water and nutrients can be delivered through liquid solutions. Oxygen can be provided by ensuring roots aren't waterlogged. Light comes from the sun or grow lights regardless of growing medium. Temperature is controlled through location and environment. Support can come from countless soil alternatives that are cleaner, lighter, and often more effective than dirt. This is why commercial operations increasingly use soil-free methods. They're not doing it because it's trendy. They're doing it because it's more productive, more efficient, and more profitable. And what works for commercial operations works for home gardeners too. The principles scale from massive greenhouses down to a single plant on your kitchen counter. Let's explore the methods that make this possible. Section 2. Method 1. Simple water culture. The simplest soil-free method is pure water culture. This is as basic as it gets. Plants grow with roots directly in nutrient-rich water. No growing medium at all. This method works best for leafy greens like lettuce, spinach, bok choy, and herbs like basil, cilantro, and mint. These plants thrive with roots in water. Here's exactly how to set it up. You need a container that holds water. Anything works. A mason jar, a plastic storage container, even a repurposed food container. The container should be opaque or covered to prevent algae growth from light exposure. You need a way to suspend plants above the water with roots dangling into the nutrient solution. For a simple jar setup, you can cut holes in the lid. These fit net cups. Net cups are small plastic baskets that hold plants while allowing roots to grow through. They cost about 25 cents each at hydroponic supply stores or online. Fill the container with water. Add water-soluble fertilizer, not soil fertilizer. Hydroponic fertilizer that's designed to provide complete nutrition in water. A basic hydroponic fertilizer costs $10 to $15 and lasts months for small home setups. Follow the package directions for mixing ratio, usually 1 to 2 teaspoons per gallon of water. Mix thoroughly. This is your nutrient solution. Place seedlings in net cups filled with a small amount of growing medium. Clay pebbles or coconut coir work perfectly, just enough to support the tiny plant. Lower the net cups into the holes in your container lid so roots dangle into the nutrient solution. That's it. You're now growing vegetables without soil. The roots grow down into the water and absorb nutrients directly. The plant grows rapidly because nutrients are immediately available and consistent. Maintenance is minimal. Top off the water as it evaporates or is consumed. Change the nutrient solution completely every 2 to 3 weeks to prevent nutrient imbalances and salt buildup. This method costs under $20 to start. A container, a few net cups, and a bottle of fertilizer. You can grow 6 to 8 lettuce plants in a shoebox-sized container. Harvest times are fast. Lettuce is ready in 4 to 5 weeks from seed. That's faster than soil growing by 1 to 2 weeks. Section 2. Method 2. Kratky method. The Kratky method is a specific passive water culture technique that's incredibly popular among home growers. It's named after Bernard Kratky, who developed it. What makes the Kratky method unique is that it requires 0 pumps, 0 electricity, 0 moving parts. It's completely passive. Fill it with nutrient solution once and let it run until harvest. Here's how it works. You use an opaque container filled with nutrient solution. The container should be deep enough that there's significant airspace between the top and the water level. When you start, seedlings are positioned so roots just barely touch the water surface. As the plant grows and consumes water, the water level drops. The upper roots are exposed to air where they access oxygen. The lower roots remain in nutrient solution, absorbing water and food. This creates a perfect balance. Roots get both oxygen from air and nutrients from water without any pumps or aeration equipment. The best containers for Kratky method are 5-gallon buckets, large storage totes, or even clean kitty litter containers. Paint them black or wrap them in black plastic to block light and prevent algae. Cut holes in the lid sized for net cups. For a 5-gallon bucket, you can fit 3 to 6 plants depending on plant type. Fill the container nearly full with nutrient solution. Place seedlings in net cups so roots barely touch the solution. As water level drops, don't refill it. Let the air gap develop. This air gap is what provides oxygen to roots. The Kratky method works brilliantly for lettuce, herbs, peppers, tomatoes, and even cucumbers. Each plant goes from seedling to harvest in one fill of nutrients, no maintenance beyond the initial setup. For large plants like tomatoes, use 1 plant per 5-gallon bucket for adequate nutrient reserves. For lettuce, you can grow 6 plants in the same bucket. When plants are harvested, dump the remaining solution, clean the bucket, and start fresh with new plants. This method is perfect for people wanting completely hands-off growing. Set it and forget it until harvest. If you want to see more survival hacks like this, hype this video so we can reach more gardeners who are ready to break free from traditional soil-based growing. Section 4. Wick system. The wick system is another passive method that uses capillary action to deliver nutrients to plants. This method is incredibly reliable and nearly foolproof. In a wick system, plants grow in inert growing medium like coconut coir, perlite, or vermiculite. The growing medium sits above a reservoir of nutrient solution. Wicks, which are usually made of cotton rope or synthetic fabric strips, connect the growing medium to the reservoir. The wicks draw nutrient solution up from the reservoir into the growing medium through capillary action. The same physics that makes a paper towel soak up water makes the wick system work. Plants' roots grow in the growing medium, which stays consistently moist from the wicked-up nutrients. But it's not waterlogged because the medium allows oxygen penetration. To build a wick system, you need 2 containers that nest together. The top container holds the growing medium and plants. It should have drainage holes or gaps. The bottom container holds the nutrient solution reservoir. Thread cotton rope or fabric strips through the holes in the top container so they hang down into the bottom reservoir when containers are stacked. 2 to 4 wicks per plant is ideal. Fill the top container with coconut coir, perlite, or a mix of both. Plant your vegetables. Fill the bottom reservoir with nutrient solution. The wicks draw solution up into the growing medium. Roots absorb nutrients as needed. You simply refill the bottom reservoir when it runs low, which might be weekly or every few days depending on plant size and water consumption. Wick systems work great for herbs, lettuce, peppers, and smaller vegetables. They're less ideal for very large, water-hungry plants like tomatoes, which might consume water faster than wicks can deliver it. The entire setup costs about $15. 2 plastic containers, some cotton rope, a bag of coconut coir, and hydroponic fertilizer. Section 5. Method 4. Deep water culture with aeration. Deep water culture, or DWC, is a step up in complexity but delivers extraordinary results. This is the method that produces those massive, incredibly productive hydroponic plants you see in pictures. In DWC, plant roots are submerged in nutrient solution continuously, but unlike simple water culture, the solution is actively aerated with an air pump and air stone. This pumps oxygen directly to the roots even though they're underwater. This constant oxygen supply is the secret to explosive growth. Roots get unlimited nutrients from the surrounding solution, plus unlimited oxygen from the bubbling air. Plants grow faster than almost any other method. Here's what you need: a container that holds nutrient solution. 5-gallon buckets work perfectly. An aquarium air pump. These cost $10 to $20 at pet stores. Air tubing to connect the pump to an air stone, and an air stone that creates fine bubbles when air is pumped through it. Setup is straightforward. Drill or cut holes in the bucket lid for net cups. Place the air stone at the bottom of the bucket. Run the air tubing from the air stone out through a small hole in the bucket lid to the air pump positioned outside the bucket. Fill the bucket with nutrient solution. Turn on the air pump. The air stone creates thousands of tiny bubbles that oxygenate the solution. Place seedlings in net cups with roots dangling into the bubbling solution. The constant bubbles provide so much oxygen that roots can be fully submerged without drowning. In fact, this oxygen-rich environment makes roots grow incredibly fast. You'll see explosive root mass development within days. DWC produces remarkable yields. A single tomato plant in a 5-gallon DWC bucket can produce 20 to 30 pounds of tomatoes over a season. That's comparable or better than a large soil-grown tomato plant. Maintenance involves keeping the water level adequate, monitoring and maintaining nutrient concentration, and cleaning the air stone occasionally if algae develops. The air pump runs continuously, using about the same electricity as a nightlight. The total setup cost is around $35 to $45 per bucket. Section 6. Method 5. Growing in inert media. The final method uses inert growing media instead of soil. This bridges the gap between traditional gardening and pure hydroponics. Inert media provide physical support for plants and hold moisture and nutrients, but unlike soil, they contain no nutrients themselves and don't decompose. They're purely structural and moisture retaining. The most common inert media are coconut coir, perlite, vermiculite, expanded clay pebbles, and rock wool. Each has specific properties. Coconut coir is made from coconut husks. It's sustainable, holds moisture excellently, and provides good aeration. It's my favorite inert medium. A compressed brick of coir costs $3 to $5 and expands to fill multiple large containers when hydrated. Perlite is volcanic glass heated until it pops like popcorn. It's extremely lightweight, provides excellent drainage and aeration, but holds less water than coir. It's often mixed with coir for a balanced medium. Vermiculite is expanded mica. It holds tremendous amounts of water and nutrients, but provides less aeration. It's best mixed with perlite or coir. Expanded clay pebbles are baked clay balls. They're reusable, drain excellently, and last indefinitely. But they hold less moisture, so they work best in systems with frequent watering. Rock wool is spun rock fiber, similar to fiberglass. It's widely used commercially, but has some environmental concerns and requires careful pH management. To grow in inert media, fill containers with your chosen medium or a mix of them. Plant vegetables directly in the medium just like you would in soil. Water with nutrient solution instead of plain water. Since the medium contains no nutrients, every watering must include fertilizer. This is called fertigation, fertilizer plus irrigation. You can hand water with nutrient solution, use drip irrigation, or set up automatic watering systems. The medium holds the solution, delivers it to roots, and then drains excess to prevent waterlogging. This method feels most familiar to soil gardeners because the technique is similar. You're just replacing soil with cleaner, more efficient media and feeding liquid nutrients instead of relying on soil fertility. Plants grown in inert media grow faster than soil, use less water, and produce cleaner vegetables with less disease pressure. Section 7. Nutrients and feeding. No matter which soil-free method you choose, proper nutrition is critical. Without soil to provide nutrients, you must supply complete nutrition through solution. Hydroponic fertilizers are specifically formulated to provide all essential nutrients in immediately available forms. These aren't the same as soil fertilizers. Plants need macronutrients in large amounts: nitrogen for leaf and stem growth, phosphorus for root development and flowering, potassium for overall plant health and fruit production, calcium for cell wall structure, magnesium for chlorophyll production, and sulfur for protein synthesis. They also need micronutrients in tiny amounts: iron, manganese, boron, zinc, copper, molybdenum, and chlorine. All of these must be present in correct ratios. Hydroponic fertilizers come in liquid or powder form. Liquid is easier for beginners but more expensive. Powder requires mixing but costs less long-term. Most hydroponic fertilizers are 2-part or 3-part solutions. Part A contains some nutrients, Part B contains others. They're separated because certain nutrients would bind together and precipitate out if mixed in concentrated form. You add each part to water separately, mixing thoroughly before adding the next part. This keeps all nutrients dissolved and available. Follow package directions precisely for mixing ratios. Different growth stages require different nutrient concentrations. Seedlings need weaker solutions. Mature fruiting plants need stronger solutions. General guidelines are seedlings at 1/4 to half strength, vegetative growth at 3/4 to full strength, flowering and fruiting at full strength. Monitor your nutrient solution with a TDS meter or EC meter. These measure total dissolved solids or electrical conductivity, indicating nutrient concentration. They cost $15 to $30 and ensure you're feeding correctly. Change nutrient solutions completely every 2 to 3 weeks to prevent nutrient imbalances from accumulating. Don't just keep topping off indefinitely. Proper nutrition is the foundation of successful soil-free growing. Get this right, and everything else becomes easier. Section 8. Advantages of soil-free growing. Why should you consider growing without soil? The advantages are substantial and often surprising. First, faster growth. Plants grow 2 to 3 times faster in optimized soil-free systems than in soil. This means more harvests per year and quicker food production. Second, higher yields. Properly managed soil-free systems produce significantly more food per square foot than traditional gardens. Commercial hydroponic lettuce yields are 3 to 4 times higher than field-grown lettuce. Third, water conservation. Soil-free systems use 70 to 90% less water than soil gardening. The water recirculates or is absorbed with minimal evaporation or runoff. In drought-prone areas, this is huge. Fourth, no soil-borne diseases. Soil contains pathogens, fungi, and pests that attack plants. Soil-free growing eliminates these problems entirely. Your plants are healthier from the start. Fifth, no weeds ever. You'll never pull a weed from a soil-free system. This saves enormous time and frustration. Sixth, cleaner produce. Vegetables grown without soil are clean. No dirt to wash off. No soil particles clinging to lettuce leaves. Just rinse and eat. Seventh, year-round growing indoors. Soil-free systems are easy to set up indoors with grow lights. Grow fresh vegetables in your basement or spare room all winter long. Eighth, accessibility for people with physical limitations. Soil-free systems can be positioned at any height. No bending, kneeling, or digging required. Perfect for elderly gardeners or people with mobility challenges. Ninth, portability. Soil-free systems can be moved easily. Rearrange your garden anytime. Take it with you if you move. 10th, space efficiency. Vertical growing is easy with soil-free methods. Grow significantly more food in the same footprint as a soil garden. These advantages make soil-free growing not just viable, but often superior to traditional gardening for many situations. Section 9. Common challenges and solutions. Soil-free growing isn't without challenges, but every challenge has a straightforward solution. Challenge 1 is maintaining proper pH. Nutrient solutions should be maintained between pH 5.5 and 6.5 for most vegetables. Outside this range, certain nutrients become unavailable even if present. Solution: use pH test strips or a digital pH meter. Adjust pH with pH up or pH down solutions available at hydroponics stores. Check pH weekly. Challenge 2 is preventing algae growth. Algae grows when light reaches nutrient solution. It's not harmful, but competes for nutrients and looks bad. Solution: use opaque containers or cover all water with black plastic. Block all light from reaching nutrient solution. Challenge 3 is root rot from lack of oxygen. If roots are submerged without adequate oxygen, they rot. Solution: use aeration in systems where roots are fully submerged, or use methods like Kratky or Wick systems that provide natural oxygen access. Challenge 4 is system failures. Pumps can fail, electricity can go out, wicks can get clogged. Solution: check systems daily, have backup plans. For DWC, have a spare air pump. For automated systems, test equipment regularly. Challenge 5 is learning curve. Soil-free growing requires new knowledge and skills. Solution: start small. Grow a few lettuce plants in a simple Kratky setup. Master the basics before scaling up. Join online communities where experienced growers share advice. Every challenge has been solved by thousands of growers before you. You're not pioneering unknown territory. The path is well established. Conclusion: there you have it, 5 proven methods for growing vegetables without soil. Simple water culture for the absolute easiest entry point. Kratky method for completely passive set-and-forget growing. Wick systems for reliable, low-tech food production. Deep water culture for maximum growth and yields. And inert media for a familiar growing experience with all the benefits of soil-free methods. These advantages make soil-free growing not just viable, but often superior to traditional gardening for many situations. Start simple. Don't invest in complex equipment immediately. Begin with a Kratky lettuce setup in a plastic storage container. Spend $20, grow 6 lettuce plants from seed to harvest. Experience how remarkably well this works. Once you've succeeded with a simple system, expand. Try different methods, grow different vegetables, scale up production. But start small and build confidence. Soil-free growing opens up food production to people who couldn't garden before. No yard? No problem. Terrible soil? Irrelevant. Limited mobility? Soil-free systems are accessible. Urban apartment dweller? Grow food on your balcony or indoors. This is truly democratic food production. Anyone, anywhere can grow fresh vegetables without soil. If this video opened your eyes to what's possible beyond traditional gardening, smash that like button and subscribe for more innovative food growing methods. Drop a comment telling me which soil-free method you're trying first. Now get out there and start growing vegetables without a handful of soil. The future of gardening is here and it's available to you right now. Happy growing, and I'll see you in the next video.